Hello, everybody. My name is Alan Garver. I'm a senior DevOps consultant with professional services in New York, working predominantly with financial services customers of AWS. And Madi and Johnny, who will introduce themselves in a little bit. The three of us are here to talk to you about DevOps transformation in the financial services enterprise. And so what we're hoping to leave you with in today's session is some tips that you can take home and hopefully incorporate into some of the projects or work that you're doing back at the end of the event. And so along the way, we're going to talk a little bit about some of the challenges we see some of the customers we work with when they're working on DevOps transformations. And we're also going to share a strategy for a quick ramp up on AWS and getting into the sort of DevOps operating model. And so we'll talk a little bit about that today. So we want to start by talking about the challenges that are in the space, a little bit, set up the problem space here a little bit. Many of you are probably working on DevOps projects. We'll talk maybe a little bit in a minute about what a DevOps model looks like as we talk about the way we think about it in Amazon. But when we talk about DevOps transformation, there's a couple of different challenges that we work on. One is the easy one, where most of us as engineers, and you're in a 300-level course, so a lot of you are probably working through some engineering problems in this space. But we think about the technology challenges. There's a lot of different technologies that we have to pick from, Chef, Puppet, Ansible, different things that we think about when we're trying to automate all the things, and struggles, challenges that we have in trying to automate some of the more complex systems that we work with in our environments. And so this is a natural place that a lot of us go, and we're hopefully going to give you a few tips on how to work through some of these with the strategies that we're going to talk about today. But there's also organizational challenges, and so these are the challenges where sometimes we come from an organization where there's some complexity to it. There's maybe a central IT organization and lots of lines of business and lots of different places where we'll see different security teams and architecture groups and things like this in our organization. And the complexity of that can sometimes introduce confusion into even knowing where to go to make a decision or how to do a certain thing in this automation capability that we're doing. And sometimes we build our automation capabilities around our organization, and that might not be the optimal way to implement things. And so we're going to talk about a little bit today about what we see some customers doing to kind of work around this or work through some of the organizational challenges. And then last is we're talking about financial services enterprises. So there are some things that are unique to us as a financial services enterprise. Things like how we're going to manage regulatory compliance, encryption, and data protection is something that's really important to us in the financial services space. And we also obsess about things like separation of duties and different things like this that are kind of unique to us in this space. And so when we start to talk about self-service DevOps capabilities, there are some interesting challenge spaces that occur there as well. So one of the things we like to do when we start to talk about to customers about this, about some of these strategies we're going to talk about today, is we kind of share a little bit of our perspective as Amazon. Amazon, as you know, is like a service culture organization. We have a bunch of product teams that are sort of managing all these self-service APIs that you know about on the AWS platform. But we didn't start out that way. In the late 90s, early 2000s, we were actually a very monolithic application. Back then, mostly an online book retailer. But we had a very large application, we had a monolithic set of development teams, and we had a lot of struggles of a traditional organization. So we didn't start out as a DevOps culture. But along the way, we sort of implemented a bunch of practices and policies as to evolve into the company that we have today. We have thousands of service teams today that are managing lots of these service primitives, as we refer to them. The industry kind of refers to them as microservices. We refer to them internally as service primitives. But we have this notion of a two-pizza team. And the two-pizza team is the idea of it is a small development team who's not larger than you could feed with two pizzas. And the size of the team kind of varies inside of Amazon, but the idea with the team is that we want the team to be small, able to make decisions quickly. We empower them to have full ownership of the capability that they're building for. And they're able to really iterate fast on their product because they have all the ownership of it. But one of the interesting things in this service model is that if you think about it, every team doesn't have to really worry about deployments, monitoring, logging in this model because there's another two-pizza team somewhere else in Amazon that's managing this capability for us. And they've implemented a service that has a self-service API and a capability that sort of farms off the responsibility of worrying about how I'm going to deploy my application to a fleet of servers or how I'm going to enable logging and how I'm going to put encryption and security into the system. And so this allows each of our two-pizza teams to really focus on the core service of the product they're trying to build on. And so this is an example of how how we've implemented this sort of organizational change. If you look at the AWS console and you see the sections of the console like compute and storage and database, that kind of maps directly to our organization. We have an organization of people that roll up that manage those compute services and those storage services. And so we've built our organization around the services that we build, which is somehow different than a lot of the traditional organizations that we work with. And so you've heard us talk about this. There was a famous talk a couple years ago at reInvent that Rob Brigham did, where he talked about, gave an internal look at our tools. He talked about Apollo and pipelines, which are some of our internal tools that we've now released as Code Pipeline and Code Deploy and other tools on the platform. But you've heard him talk about this, and in that talk he shared that we do 50 million deployments a year at Amazon. And how we accomplish something like this is because we have these small teams that are managing service primitives, these small service primitives, and they're all releasing at will through this self-service set of deployment tools that we've built. And so we see a lot of financial services enterprises working on this today, trying to implement a similar kind of model where this self-service deployment capability on a platform like AWS that allows them to implement small services to be deployed at will through a self-service API. And what we learned about our transformation is it took us about a decade, somewhere around a decade, to actually make this transformation from a monolithic organization to the service culture that you know today about Amazon. And we learned that there's challenges in these different spaces that we really needed to put a holistic approach together to go and solve these issues. And so what we're hoping to today is to share with you some strategy that we see a lot of financial services enterprises working on that we've worked with to try and accomplish a similar sort of transformation in their culture. And when we think about what organizational transformation is, we think about it in this idea of taking all the things that we do and automating them, and maybe automating them as a self-service, single-purpose API, right? So from this point on in the talk, Madi, Johnny, and I are going to refer to a developer in a couple of different scenarios. When we talk about a developer could be the traditional application developer that we know, that maybe many of you know today, which is somebody who's writing Java code and worrying about the internals of an application. But it could also include somebody now that's developing infrastructure as code, something like CloudFormation, which is our infrastructure as code service, where you would actually now software define your infrastructure. And that could be included in what we refer to as a developer. So there's a wide range of what's going on there. And so we'll talk about that. But when we start to talk about service cultures and start to talk about deployment automation, which is usually one of the first places we go when we talk about DevOps, is we talk about the pipeline. And the DevOps pipeline, many of you know, you're probably already working with a Jenkins system or maybe using AWS Code Deploy or Code Pipeline. The pipeline itself is how we get from code, a source code repository that has code in it that defines what we want for an application, out to a running set of configured production infrastructure where our customers usually live. And it gives us a lot of confidence that things have been tested in this process. There's a bunch of automation in there that kind of chains together all this code and testing so that when the change finally gets to the customer, we have confidence that it's stable. But when there's a failure, when there's something that fails, it actually can stop that thing from getting out to the customers, and it can give us fast feedback on what the problem was, and the developer can, instead of having to retool from what they were doing, can quickly fix the problem. And when we look at a lot of the customers that we talk to today, many of you are probably already working with Jenkins or Bamboo or maybe Code Pipeline, and you're already incorporating some of these maybe CI processes into what you're doing today. So you'll have a Java developer who's committing code to a repository, writing their application code, and then some Jenkins system will wake up on the commit. It will run a bunch of unit tests, it'll compile that code, it'll send it out to an artifact repository. But what transformation starts to look like when you go to work with a cloud provider like AWS is you start to incorporate infrastructure into that code. So we're going to talk a little bit about that today and some techniques that can kind of help as you're incorporating this. But when developers are now including the infrastructure code alongside of the application code, it kind of changes the way the pipeline behaves. And so we can incorporate infrastructure tests and actually push that code, not just compile it into an artifact system, but we can actually install it on a set of running systems and test it and give it over to our customers full through automation. And so when we give self-service access to a pipeline capability or an end-to-end capability like this, it's easy to see how something like 50 million deployments a year can be accomplished in a model like this. If you have a bunch of teams that are all managing a service and all able to release things at will and write their own code and write their own infrastructure around it, and they have a self-service set of deployment capabilities, you can really scale out quickly here. But in the conversations we have, we say, okay, well, hold on. This is a financial services organization. We have a lot more requirements than you do, Amazon, right? So we hear this a lot from customers. And so There are concerns here around regulatory compliance and things like separation of duties and stuff like this that come into the mix when you start talking about self-service capabilities that we worry about all of our developers doing good things all the time. And so, people will say, hey, if we just self-service enable everybody and they start deploying CloudFormation, won't they just send a bunch of stuff out of the environment and now we've got a whole bunch of things to worry about? And so our mission with the rest of the talk is to kind of give you 3 strategies that will help scale up quickly, ramp up quickly on using infrastructure as code on AWS, and putting in the control guardrails that are necessary to prevent from spreading bad things around the environment, and then some of the scale problems that come with that. And so we're going to kind of talk about it in 3 quick steps. The first one is we'll talk about implementing a cloud governance model. And then once we establish this governance model, we're going to talk about what that is and how to do self-service infrastructure on AWS through this governance model. We're going to talk about some of the scale problems that introduces for us as an organization that we see really common in this space, and how to work around that through some automation. And then last, we're going to talk about how to implement some guardrails at self-service guardrails at scale. So first, we want to talk about policy enforcement. When we talk about policy enforcement as it relates to centralized governance, something like CloudFormation allows a developer to implement EC2, S3, all the things as code, but we want to enforce a bunch of policy like around making sure that people are doing things like encrypting EBS volumes, when they're creating security groups, not setting the ingress to be 000/0 in the CIDR block, things like this that we want to enforce as policy that we've engineered. And so what a lot of customers do is they start out by tasking a small team, maybe a cyber team or somebody, with the responsibility of understanding what good looks like. And then we pass all of those CloudFormation templates through this team, and they kind of look at them, examine them, and certify them. And you might do this through a commit, a merge request in a Git repo, or some method that we've seen to do this, but inevitably a team is reviewing all of your things. And then once they're reviewed, they're put into some sort of authorized place, and your developers then get self-service access to that, to launch from that place on AWS. And so Madi is going to come up and talk to you a little bit about Service Catalog. It's our cloud governance first step in the model here, and he's going to talk about Service Catalog and what kinds of things it can do for us in this space.
Thanks, Alan. Hi, everybody. My name is Madi Sajakpour. I am a BDM with the Service Catalog team. I specifically work with East Coast customers in the US. I'll be talking to you about Service Catalog and also talking to you about self-service infrastructure. And I want to put kind of some definitions around when we talk about self-service infrastructure and what that means and how to interpret it. So we have kind of 2 definitions around it. I'll use an example of a baker. So let's say I have a bakery shop and I create, let's say, blueberry muffins all year round. It's my highest selling item. I keep making them over and over again, and I have a specific recipe for it, I have a specific mold for it, and I'm constantly building that out and selling it to my customers. So that's what we kind of call a standardized pattern. Let's convert that to, let's say, into infrastructure terms. So let's say I have a Linux machine. It's consistently the same way every time I launch in my environment. It meets all of my compliance requirements. Let's say it has EBS encryption on. It's meeting all of my requirements. I have the same thing for databases, the same thing, let's say, for an EMR cluster, the same thing for an S3 bucket. Now, let's think about the next step. Let's say I'm a baker, and now it's like fall, and I want to build something very specific for the fall season. So let's say I decide to build, let's say, a muffin, which has, let's say, pumpkin spice in it, and it has chocolate chips in it, and I want to change the mold around for it. So that's what we kind of call like a purpose-built pattern. So there's a pattern, let's say, specific to an application. I want to build, let's say, a particular set of servers that get launched together and do X, Y, or Z. It's very specific to it. And what I really want to accomplish is all those things that I've listed here. I want to have faster innovation. I want to make it repeatable, scalable, and I want to make sure I'm meeting all of my security requirements. So what do we want to really gain here? There's 4 things we kind of want to really gain when we talk about self-service infrastructure. 4 things. One is ease of use, right? We want to make sure the developers are happy. They are able to go and launch what they need, whether it's a simple Linux EC2 machine, or whether it's an EMR cluster, or whether it's something that they're purpose-building for themselves. We want to make sure we have agility in that environment so we can get things really, really quickly. So I want to make sure that I can scale this also as well, and also meet my governance requirements. So what do we mean by all that? So let's say I have 500 application teams, 50 to 100 of them know CloudFormation really, really well. They can write their own purpose-built applications. What about the other 400? I want to make sure the other 400 are able to use the agility in AWS and be able to launch really quickly in that environment. And I know that I have repeatable common application patterns that I use across my organization. So I want to enable them as well and scale organizationally and give that agility back to my teams. I want to make sure I'm meeting all of my governance requirements. I have security enabled. I'm meeting all of my requirements from a security point of view, and I want to be able to track things, let's say through tags. So what do we need to get there? These are the kind of 4 things to be able to get to the self-service model. One is to standardize. So let's say we like to standardize on CloudFormation. So let's say I build everything through a CloudFormation template. Now I want to make sure I enforce all of my policies. Let's say EBS encryption is one of them. Let's say I have to be in a particular security group. These are my requirements, et cetera. I need to integrate with X, Y, or Z. I need to make sure all those are there. So I want to enforce policy. AWS Service Catalog helps you specifically with those 2 things right there, standardization and enforcing policy. It can help you also with other things, but let's also put some definitions around that. So let's say I want to integrate it with the rest of my IT ecosystem. So let's say I have ITSM, CMDB, I have to do my logging and monitoring, I have to notify X, Y, or Z team. So I need to make sure it works within my environment and meets all of my requirements. And I want to automate it, because when I can automate, I can scale, I can make it much easier for people to be able to leverage the environment. And we'll get into all those in the next couple of steps. So let's talk about standardization, standardizing around CloudFormation. We love to use CloudFormation to standardize, to build, let's say, an entire stack. So whether it's a Java stack or a .NET stack that your organization uses, or whether it's just an EC2 Linux machine or an RDS database. You can build it with JSON, you can write it with JSON or YAML, and then build a stack out of that, and you can launch anything from a single resource to multiple resources within AWS. What Service Catalog does, it takes that template that you built with CloudFormation, and you could turn it into a product in Service Catalog. But what Service Catalog allows you to do is to make that product immutable and let it be available to end users so they can't change it. So you have all of your policy enforcements enabled and in there. So what Service Catalog is really trying to do is solve this problem we see with multiple organizations. We have end users, they want to be able to launch resources really fast. They want to have the agility in the environment. They want to have self-service capability. They want to hopefully have faster time to market. But from an organizational point of view, I need to make sure I meet my control, standardization, and governance requirements. I need to make sure all my tags are set. I need to make sure all my security requirements are there, et cetera, et cetera. So that's what Service Catalog is going to enable you to do. So I built a set of repeatable common application patterns that I have, and I provide it to my end users. So you can standardize with CloudFormation, build a CloudFormation template, turn that into what we call a Service Catalog product. So let's say I just create a Service Catalog product for a Linux machine. Now I can have a consistent environment. So between my non-production, production environments, let's say my dev, QA, and prod environments have the same kind of Linux machine that are being launched in all 3 environments. I limit access to the underlying service. So with Service Catalog, if somebody can launch, let's say, an Amazon EC2 Linux machine, they won't necessarily have access to the EC2 service. They will only be able to launch a product which will actually launch an EC2 instance. They won't have access to EC2. So they won't have to sit there and build IAM policies which are specific to a given application. And you can enforce up to 40 tags per launch. So every time I launch a resource, if it's a taggable resource, you can have up to 40 tags that are being enforced in it. What does that give the end user? It gives the end user the ability to have autonomy. So if I'm a developer, I can go in and just launch any service I want. You are enforcing your guardrails, so the templates that have been turned into Service Catalog products cannot be modified, and I can automate my deployments with the CLI or the API for Service Catalog, and I can have a single pane for provisioning in AWS. So let's go back to when we talked about the standardized versus purpose-built patterns. So if you have a standard pattern, it's a common infrastructure pattern. Let's say you have 5 to 6 patterns, 10 to 15 patterns. You could turn those into CloudFormation templates and put them into AWS Service Catalog, and that enables end users to be able to launch things fairly quickly. But let's say I want to do something different. I want to go deep into AWS. I want to use multiple services. I want to build something very specific for my application. I still want to be able to do that, and we need to be able to enable that and make it easy for users. I want them to be able to innovate. I want them to be able to do other things. There's additional requirements there in terms of security and automating things, which Johnny will talk about in a couple of minutes. So let's just kind of look at what it looks like for a developer. We're kind of proposing 2 paths for a self-service infrastructure. One is I go to AWS Service Catalog. I want to launch something. I find what I want. It's a pre-approved, verified pattern. I can make it immediately available, and I can get the resource immediately and use it. And it's already pre-approved, so I don't have to go through any additional processes. But let's say I want to write my own CloudFormation template. I want to have a purpose-built pattern. So it requires some additional security checks, which Johnny will talk about how to automate that process. And I want to make sure, it will have a longer provisioning time, but I still want to make sure I will be able to build that pattern and be able to leverage it. And maybe I will have a template. I build a purpose-built pattern that's repeatable, and then I'll turn it back into a Service Catalog item in the future. So let's take a look at how that looks like and what that path might be in terms of integrating it with your other systems within your IT environment. So let's say I want to launch a standardized pattern. I go and launch Service Catalog. I need to update my ITSM system. I'm only using ITSM here, but you probably have some logging or monitoring, additional systems that need to get updated. You need to have a record in your SIMDB, et cetera, et cetera. And then I launch my stack, and I have it available. What if I want to build my own CloudFormation template and have a purpose-built pattern? So if I go in and launch a CloudFormation template, I have to write my own template, let's say check it into Git, and I have to go through some security controls to make sure I'm meeting all of my requirements. I might get approved the first time, I might not get approved the second time. We'll talk about how to automate that in a couple of minutes. And then let's say I have to update my ITSM system and eventually launch my stack. So what does this mean in terms of an enterprise adopting DevOps and moving towards that path? What we see is what you can do is build a set of CloudFormation templates, turn them into Service Catalog products for your commonly repeatable application patterns. Think of this as a ramp to being able to enable DevOps, because you're going to let all of your users be able to use AWS fairly quickly. They don't need to have deep knowledge of every service to be able to build their own patterns or build their own CloudFormation templates. They just come there and launch AWS services immediately. And then over time, you still want to have a path so they can still create purpose-built patterns, because they will be able to leverage that as well. Because you want them to innovate, you want them to build new patterns and try new things. And gradually, as your team becomes more aware of AWS, and let's say you have 500 application teams and they gradually learn more about AWS, you'll gradually build more and more purpose-built patterns. So with that, I'll hand it back to Alan, who's going to talk about governance at scale.
Thanks, Marty. So Marty shared a little bit Service Catalog and how we can use that to determine or build our policy establishment around AWS services, and build in a capability that allows us to create self-service interfaces to standardized infrastructure on AWS. But he also talked about building purpose-built patterns. And so we'll come back to that in a minute. But think about what the capability that this gives us. It says when everybody in the company wants to come, if we're using a service like Service Catalog, it allows us to create these reusable authorized templates into a portfolio that developers can come along and select and launch onto AWS as part of their pipeline. But it really requires for everything that goes into that portfolio to be certified by our policy and enforcement team. And so what happens when a developer comes to the catalog and what they're looking for isn't available in the catalog? Or what if the developer finds something in the catalog, but it's not quite what they wanted? There's something about that pattern that they would want to tweak slightly. What has to happen in this case? And so in order to launch anything in this model, we have to bring the developer to the Service Catalog portfolio. In order to do that, new patterns have to come through our policy enforcement team in this model. So this means our policy enforcement folks are going to be getting requests from various teams around the organization, and they're going to have to remember and know all of the policies and the rules by which we want to enforce in these templates. And so very quickly we learn this is a very intensive process. The more services we enable the teams to use, the more capabilities they want to take advantage of, the more rules they have to remember, and the more things they have to catch in the template. And if we're handling this through merge requests and something like a Git repo, every single merge request that comes in for policy enforcement has to go through a review. It's very easy to see how these folks can very quickly become overwhelmed. Right? And then the more people that are using self-service capabilities that we introduce with Service Catalog, there will be more and more of these requirements and requests coming in. And it's very easy to now see how underwater our policy enforcement teams. And I venture to say many of you might be in this scenario today, where we're trying to certify through some central process every single pattern that we deploy onto AWS and every customization of that. And so one of the things we want to do right away is we think about this governance bottleneck and what it means to the policy enforcement group. We have to introduce some automation to make their lives easier, to make it easier for them to scale up and to be able to handle all the requests and capabilities that they're bringing. And so we start to talk about policy enforcement automation here. And the idea is that when we establish a policy like, thou should encrypt all EBS volumes on AWS, we want a way to codify that and a way to automate the check of something like CloudFormation. And we want to incorporate that into our automation policy. And so when we bring a new pattern to the policy enforcement folks, that pattern is something they can quickly pass through the engine, and it will tell them, all of the policy that you've established to date is satisfied by this template. So it helps improve the ability that they have to scale and handle all of the requests that are going to come in from the organization. And so this brings us to the next step in our process. How do we scale up a governance process like Service Catalog to be able to handle all of these nuances? And fortunately, we have a business partner who's written an open source utility called CFN-NAG. And Johnny's here. He's going to talk to you a little bit about CFN-NAG, what it is, and how it can help here.
Thanks, Tom. All right. So, hi, everybody. My name is Johnny Civilak. I'm a senior DevOps automation engineer with Stelligent. We're an Amazon Premier Consulting Partner with the Financial Services Competency. And I'm really excited to be here today to talk to you about one of our open source utilities that helps with this policy enforcement that Alan was just talking about. So we've had this picture of the build, test, deploy pipeline. And one of the little gotchas with CloudFormation is when you build a CloudFormation template, you're actually instantiating those resources. And this brings up two issues pretty quickly. The first is that can take a while. Some Amazon resources can take a really long time to provision. And if you're sitting around waiting for your RDS stack to come up, you're going to get bored really fast. The second problem is because we're instantiating those resources, if there was a problem, a security policy problem with our template, we just instantiated that infraction. So it'd be nice if we could test our template and not have to test the resources that come out. And that's where CFN-NAG comes in. It does analysis of CloudFormation templates, not the actual provision stack. So it's nice because you get that feedback very, very quickly. And because it's just a simple command line utility, you can run it on the developer laptop or as part of your pipeline to enforce that compliance every time you build, test, and deploy. Gives you the ability to prevent these resources from being provisioned if they don't meet your policies. So what kind of things does CFN check for, or CFN-NAG check for? Just really common anti-patterns that have been discovered through creating lots of CloudFormation templates. So a really common one is security groups that are open up to the world. You probably never ever want to do that, but it's a very common troubleshooting technique. If you're building some infrastructure and you're getting some sort of network problems, the first thing you tend to look at is the security group. And then once it's working, you always forget to lock it back down. A similar problem with IAM permissions. You are building an IAM role and you are trying to figure out something that's not working. So you just assign administrative privileges to that role. You keep working on it, get it working, and forget to lock it down until 6 months later when you stumble across it looking for something else. Both Madi and Alan have mentioned EBS volume encryption. This is something that there's really no reason never not use, but it's not turned on by default, and a lot of people tend to miss it. And those are just really common things that are useful for everyone. CFN-NAG is an open source utility, so if there are policies that are useful to your organization specifically, you can go in and add those in and have them be part of your pipeline. So I'm going to do a quick demo of CFN-NAG. I think I remember what button to hit. Yeah, all right, cool. So the first thing we're gonna do is just install CFN-NAG. It's pretty easy to install, it's just a Ruby gem. So it's just gem install CFN-NAG, assuming you have Ruby installed. If not, we're gonna leave that as an exercise to the reader. But let's start running it. So I have a pretty simple CloudFormation template here. All it does is just provision the EBS volume. And you'll notice that it's specifically set to not be encrypted. So let's see what CFN-NAG thinks about that. So I'm gonna switch back over to my terminal. I'm going to call CFN-NAG scan, and then I'm gonna pass in an input path to that volume template that I created. And CFN-NAG comes back saying that we're not encrypting that volume, and that's a problem. So through the magic of preparing all these in advance, I have a template that actually is working. So let's compare those. And it's pretty easy to see what we changed here. All we're doing is setting the encrypted property to true. So that's a simple example. Let's take a look at something with a bit more meat to it. Actually, let's run it against the working template. So this is what it looks like when CFN-NAG is happy. It comes back with no issues. So that's like now it's like a template with a bit more meat to it. So this is a CloudFormation template that might be similar to what you have working in your environment. It's a EC2 instance with a EBS volume, a security group, and an IAM role attached to it, and it's sitting behind a load balancer. So let's run this through CFNAG and see what it says. So again, we're going to call CFNAG scan. We're going to pass in a path to this template, which is creatively named stack. And this came back with a lot more information. So the thing I want to point out here, CFNAG comes back with two types of errors. The first type is failures. These are anti-patterns that are known to be troublesome and you don't want them full stop. It also has warnings, which are patterns that are probably not any good. So for example, on the second one, it's complaining that the load balancer does not have logging enabled. In production, you definitely want to have logging enabled for your load balancer, but maybe in like a performance testing environment where you're generating a lot of traffic, you'll be generating a lot of network logs that you're never really going to need to look at, so you probably don't want to have to pay for them. So you might want to skip it in some environments. But it is definitely something you'd want to like think about and make sure that you're doing it for a reason and not just doing it by accident. So let's take a look at the fix stack, or fix template that has all the changes in it to make CFNAG happy. So the first one here is the EBS volume is encrypted, just like the last example. What's different from the last example, I'm just highlighting that you don't need to have the encrypted property in your CloudFormation template, which makes it really easy to forget it. So a lot of your EBS volumes are probably not encrypted because it's just not required to have it there. The second failure that came back was around the IAM role. In the action field, we were allowing it full permission to hit all the Amazon APIs on our account. This is not something you probably ever want to do. I've worked on a lot of Amazon projects, and I've yet to find a use case where an IAM role needed full access to every action in the account. That said, I've stumbled across a lot of templates that have this full admin permission. So it's a very common anti-pattern, and CFNAG will check for it. So in our example, we'll just say we have a web server that's uploading files to S3. So the only action we need is S3 put object. So we fixed that. CFNAG also came back with a warning that we were allowing it access to every resource, which you might want to do. There are some use cases where that's useful. But a lot of the time, you really want us to lock it down. So in this case, we do want to lock it down to like that specific S3 bucket. And the last set of messages that came back with were about the security group. So here, we had two issues. The first is we had the full port range open. You probably never want to do that. So we're going to lock it down to port 80 so that it only lets HTTP traffic through. And because that traffic's only coming from the load balancer, we're also going to lock down the CIDR. It's right in the left example, it's open up to the world. And the right example, we're locking it down to our VPC, assuming that's our VPC's CIDR block. So let's run that through CFNAG and see what it thinks about that. And it comes back with only that one warning about the load balancer logs that we talked about. The thing I want to highlight here is since it only came back with a warning, if we look at the return code, it came back with a success. CFNAG treats failures as breaking and will stop your pipeline there. It treats warnings as warnings and will continue to let your pipeline continue if it hits those. So you don't have to worry about warnings blocking your pipeline all the time. So that's the end of the demo, and awesome. So that is a quick explanation of how CFNAG works. If you want to learn more about how you can use CFNAG in your organizations, there's 2 more talks this week. Tomorrow, my colleague Casey Lee will be talking about how they use CFNAG and other tools to achieve autonomy and governance at 3M. And then on Friday, our VP, Chuck Dudley, will be talking about how they used CFNAG at Verizon to achieve automated security validation. Thank you so much. There you go.
Great. Thanks, Johnny. So coming back to our big picture here, so we talked initially about using Service Catalog as a ramp to establish self-service infrastructure to standardize templates on AWS and the scale problem that it introduces. And then second, Johnny shared with you CFN-NAG to talk a little bit about how we can help those policy enforcement folks scale up to be able to handle the demand that's inevitable in this model. And so when we think about it, we come back to our policy enforcement folks, and we think about what we've just done with CFN-NAG. At some point, we become confident enough in the policy that we have there that we can think about self-service enabling an interface directly to CFN-NAG and giving all of our developers the ability to take their CloudFormation templates and call CFN-NAG and all the policy that we have that we've built into it as an organization so that they can enjoy self-service access right to the pipeline. And so this is kind of the next step in the journey. This is where we're kind of releasing the teams to not have to come to our policy enforcement folks in the financial services enterprise anymore because we're confident in our policy automation to allow them self-service access to AWS. And this is where we start to see large-scale implementation. And so one of the things that we see a lot of customers challenged with in this space is that now that we've enabled self-service access to the pipeline, many of you are probably doing this today where you're writing your own bash code in Jenkins jobs and everybody's got the ability to create jobs inside Jenkins. We worry about making sure that everybody in the company can actually have this self-service access and still enforce the idea of something like CFN-NAG to make sure the guardrails are there. Right? So we want to make sure that there's no way for a developer to bring a new template, incorporate it into the automation, and somehow bypass our policy automation. We want to try and prevent this. And so the next step in the process is to kind of talk about, all right, well, how do we move to that next level? How do we really self-service enable free range to it and put a policy engineering process in place to allow us to improve that policy engine, but give people full self-service access to it and enforce it at scale? And so one of the things that we talk with a lot of customers in this space and what a lot of financial services enterprises are doing is implementing simple orchestration to go build a capability like this. And so what do we mean by orchestration? We really mean a simple, consistent interface that makes it easy for developers to do the things that you're trying to do in your deployment system. Right? So if you think about the AWS platform and what you can do on the AWS platform, we think about orchestration kind of like we think about the AWS CLI. Many of you have probably done pip install AWS CLI, and it doesn't matter what service you're trying to interact with on AWS, whether it's Redshift or Kinesis or Lambda or DynamoDB or EC2 or S3. You can go to the API, the CLI, for all of those things. It's a common, consistent interface for all of the services that are available to you. And we think of that, that's kind of the idea of an orchestrator. It's to take an experience like that, bring all of the capabilities you have into a central interface, and give everybody access to all the things. We've shared with you a couple of patterns already in the talk. The first, we talked about launching products or provisioning products from Service Catalog. That's one path that your developers might take in their journey so far. The other one is launching pure CloudFormation, doing a create stack call to CloudFormation. And so we kind of want to create a consistent experience for the developer. But what about things like Chef, Puppet, or Ansible, logging, monitoring, all the other things that we have to worry about in our system? How do we bring that consistent experience to the developers? And so when we say orchestrate all the things, we're kind of talking about a couple of things I've already shared, talking about making things a common, consistent interface for folks. But we also want to simplify tasks. Take, for example, the create stack call to AWS CloudFormation. When a developer brings a CloudFormation template and they want to do a create stack call, instead of giving them direct access to create stack, we can give them an orchestrator capability and orchestrate the capability for them that allows them to, that enforces the CFN-NAG scan right into that process. And so every time, they're going to create stack with a single command, but it's going to give them CFN-NAG for free. Right? We also want to make the functions portable. Many of you are probably managing Jenkins jobs on a Jenkins system somewhere. And you think about it, maybe in some of the larger implementations we've seen, we have tens of thousands of Jenkins jobs on a large farm of Jenkins servers. In those cases, you probably have a lot of redundancy in that system. Lots of pipelines that are redoing things like Maven build and unit tests and all this kind of thing, where you look at the number of jobs that you have these doing, there's a lot of repetitive things happening in there. And now imagine for a minute that as an organization, you want to change the way you're doing that behavior. You want to add some step consistently across the organization to how you're handling Maven builds, for example. It's going to be challenging for you to go find all of those jobs and then implement them all over the place. Another thing an orchestration capability might be able to do is airlift that specific logic out of the Jenkins job itself into something that you can pip install and make it portable. So now a developer can put it in their workstation, but it can also be used across all the different implementations of that pipeline that you're running in your Jenkins system. And then the other thing is we want to be able to bolt in those guardrails. So if you're going to launch from CloudFormation, let's make sure that you do CFN-NAG every time, right? And so we can orchestrate that experience for the developer. I want to make a quick note here. We're talking about orchestration here and not abstraction. So abstraction is something different. Abstraction is something we see a lot of customers trying to do to prevent vendor lock-in. And this is not something that's just specific to the cloud provider. Of course, the vendor lock-in on the cloud provider is one thing, but we see it across many different things. And abstraction here, if you think about what abstraction is trying to do, is it's trying to prevent vendor lock-in. It's actually going to introduce this thing we refer to as least common denominator. It's going to limit your use of capabilities based on the capabilities that are available to all the providers you're trying to enable. And so its mission as an abstraction layer is to take away capabilities. Orchestration is different. Orchestration is about making it easier to consume all of the individual things by each product and each service that you're trying to implement. And so the mission with an orchestration capability is to make it easy for a developer to do things quickly, so you reduce costs that way and consistently, but also to enforce all the guardrails, the things that you want to ensure that you protect as you're building all this automation into your delivery systems. And so if we come back to the pipeline that we've been talking about along the way, what do we mean by orchestration as it relates to the pipeline? Well, if you think about what the developer is trying to do in AWS, and we're trying to incorporate now infrastructure into what we're doing, we want them to be able to write CloudFormation and Chef recipes and Java code and all the things that are required to deploy their tech stack, and we want them to be able to iterate and test on those things in the development environment. But when they're doing that, we want to increase the level of confidence they have in what they're doing there so that when they actually commit and make that change to the repo that they're writing that code against, that the pipeline, that we have a high level of confidence in the pipeline's ability to go execute that. So a lot of customers start out by implementing something like CFN-NAG, but the first time a developer actually gets to see what's happening is inside the pipeline. And what this does is it increases the likelihood that you're going to have a failure event in your pipeline. It's going to turn your pipeline red. And for those of you that are managing through continuous delivery pipelines and the experiences that you have around that, you know that a red event in the pipeline, usually most customers want to treat that as like a high severity event. You want your pipeline to turn red very infrequently. It should be a thing that you try and avoid, and when it does, we should treat it like a SEV1. Right? Our ability to release updates to our customers has been broken because our pipeline is now unable to send a new update. And so we want to treat that like a SEV1. We should avoid that situation at all costs. And so in this model, what we want to do is give confidence to the developer when they're writing the CloudFormation or the Chef code in their unit development environment. We want them to have confidence that whatever they are about to commit to the repo is actually going to run successfully in the pipeline. And we do that by giving them access to the functions that are in the pipeline in a very easy, consistent, orchestrated interface. And so when they make the commit now, we know that the commit's going to run through the pipeline with confidence and deploy whatever that thing is out to our customers in a fully tested way. If we still miss something, we still have the pipeline there to protect us. It prevents bad things from getting out to the environment. But we've reduced the likelihood that we're going to cause a failure or some sort of error in the pipeline. But in order to do this, we have to have confidence in the ability to be consistent in what's happening for the unit developer in their development environment, as well as what's happening inside the pipeline. And so we do that by creating this orchestration experience. And oh, by the way, one of the things that you get with this, if the developer can be confident about what they're doing in the unit development environment, and they know that that same experience is going to happen in the pipeline, they actually don't even need access to production. Right? They won't need access to any of the infrastructure that's being managed by the pipeline. And we really like this in financial services because this means we can really maintain segregation of duties or separation of duties to a really like obsessive level here. Sometimes I see customers implementing break glass scenarios and different things to get into the production environment. But the good news is the instances of that can be significantly reduced by ensuring that we have a consistent experience in the development environment with what's going to happen in the pipeline. So I'm going to share with you, I'm going to use the rest of the time to share with you a very specific example here of implementing an orchestration capability through a command line interface. My hope is to press upon you how easy it is to build a command line interface that orchestrates a lot of capability in your deployment systems. We work with a lot of customers that are implementing projects that do this, financial services customers specifically, and so I'm going to share with you an example here. You know, what I've seen customers do in a sprint or two by building their own CLI for all the deployment systems that they want to build against is amazing compared to how much time we spend talking about, you know, should we implement Chef versus Puppet, right? So, you know, this strategy is something that doesn't cost a lot to go try. I'm not going to share anything in here that's like mind-blowing or unique. It's very simple stuff. But my hope is to make it seem easy to go do this. And so what we want to do with the CLI is make an interface that everybody knows to come to, something like the AWS CLI. Everybody knows to come to it when they think about deploying things in our environment, wherever that is. They come to that interface and they can get a list of all the things that are possible for them in an interface that simplifies all the things they're going to try and do in a deployment system. The example I'm going to share with you is something that you can find very easily. It's an open source project actually called Python Click. If there are any Python developers in the room, you may have come across Click. It's a very good open source module for producing command line interfaces very quickly that are really robust, and it's got a lot of capabilities in it. Specifically, the examples I'm sharing are all based on the Python Click complex example. At the end of the talk, I'll have a link to the GitHub repo for Click. I would encourage you to go check it out. It's very easy to use. But it's very simple to implement. So what you're looking at here is a single command that's exposed in a CLI called list portfolios. And list portfolios is not really doing anything crazy here. It's actually just instantiating a Boto3 client. You can see it instantiate the Service Catalog client. And then it calls the list portfolios operation from Service Catalog. It ingests that into a variable, and then the rest of the code, the rest of the very simple 21 lines, is really just outputting that code. And it's not even really that great. You could probably simplify this a lot more than it is. But down in the lower right, you can see now, because we've implemented this, all I've had to do on this system is pip install Dory. Dory is the name of this. It's short for Deployment Orchestrator Interface. I can call this this particular operation, this list portfolio operations, which I've put into a handler called Service Catalog. So this is a Service Catalog handler, and the operation is list portfolios. So now I've customized what the developer's experience looks like when they're interfacing with AWS's Service Catalog. And you can see this is an example output from that command. It's just printing out some portfolios that I can see. So this is a very simple example. You might not use this particular operation in a pipeline. But you might not use this operation in the pipeline. But the idea here is we've created this very simple orchestrated interface for our developers, and we can make it consistent for everybody. Everybody knows to come to Dory to find Service Catalog operations and implement them. I'm going to go up a level here. I'm just doing a directory listing of what's in the Dory directory. So when I pip install Dory, these are the things that are built into this particular Python package. I have just one file. It's a cli.py. And again, I'll encourage you to check out the complex example. It's all there on the GitHub repo, very simple. But there's a folder in there called handlers. And inside of it, I put each one of the handlers that I want to teach my orchestration system. So in this case, I've given my orchestration capability Chef, Code Commit, Code Pipeline, and Service Catalog capabilities. These are each handlers now that my orchestration capability has. And I can go a little bit further and go into each one of those and ask Dory to tell me what operations are available there on the command line. In the lower right, I can say Dory -- help. This is what I get for free with Click. And it prints out for me some interesting command line type look and feel stuff. So I can see I have 4 high-level commands that are available to me. Notice I didn't have a CloudFormation handler, so let's build one real quick. To add capability to this Click complex example, I simply go and create another directory. This is a CloudFormation directory. And I'm going to teach this CloudFormation handler how to do 3 operations. I'm going to teach it how to create stack, how to list stacks, and how to scan template. And so this will bring together all the elements of the talk today. Johnny shared with you a little bit about the CFN-NAG scan command. I can actually orchestrate a command into my CLI that will just call CFN-NAG scan against a template that I can provide as a variable to this command. And so I can create that capability for all my developers, and now my developers don't have to hunt to know how to get to CFN-NAG. It's all in this one interface along all the other tools that they use. And so additionally, I could take something like the create stack call that's here as well. I'm not going to go into details about what these commands do, but you can imagine that if I'm going to give the developer the ability to actually make an API call to AWS to create stack with a CloudFormation template, I can actually bolt right into that operation CFN-NAG scan, right? So I can make sure that every time we do a create stack call, we're going to get a CFN-NAG scan with that call. And then when we run this in a pipeline, this operation's running in a pipeline, for example, if that scan fails, the stack won't create. There'll be an error in the pipeline, and that error will be fed back to the developer. But more importantly, the developer can actually go experience this behavior right in their unit development environment. So now we've got this consistency between what the developer experiences when they're writing the cloud and testing the CloudFormation that they're writing before they actually make the commit to their repo, where the pipeline will wake up and carry it out to the users. So let's add this CloudFormation handler into Dory. We just simply drop that directory into our handlers folder, and now we've got the entire CloudFormation handler available to all of our users. Imagine now this is part of a larger software development capability where we've got our own package index for Python things that we deploy across the company. We can simply push this update out to our Python package index, and now all of our developers can pip install or pip update, and they have access to all the latest and greatest that we have. Also imagine now we've got tens of thousands of Jenkins jobs running in our environment that are doing create stat calls, and we've just enabled this new CFN nag scan capability into that. We simply push the update, our pipelines can all update themselves, and now maybe we had 30 pipelines go red in this process because there's some people that have failures, but that's the desired outcome, right? We want our developers to be aware. We want to cut sub 1 tickets when there's a security or a policy violation somewhere in our system, but we've now centrally managed it, we've made it more scalable, and we've reduced the amount of labor it takes to manage all these Jenkins jobs around the organization. So hopefully this helped a little bit. What we've talked about here is this idea of enforcing at scale. Enforcing at scale is really about the ease of use for your developers. If we could take a very simple CLI, and you've seen there's really not a lot of complexity to what we're talking about with the example that I've just shared with you. Most customers that we work with in this space can iterate very quickly and build some really interesting capabilities in a sprint or two that is very usable and makes the experience really good for the customers. But the real value of what we're producing here is we're creating, maybe it's a 2-pizza team, maybe it's not, but the experience is that we want to treat our developers in the company as customers. We want to actually make their process and their experience deploying anything into any of our systems very easy. We also want to make it modular. If somebody brings a new capability, we didn't talk about it before, but teach your CLI how to do as many different capabilities as you want. If you worry about selecting Chef, Puppet, or Ansible, give it all 3, right? Teach it how to do all 3 and let the developer pick what they want to do. If you're arguing about whether to use CloudFormation or Terraform, give your CLI both capabilities. Let it deploy with CloudFormation or Terraform, right? And that's the idea here, is that when we talk about orchestration, it can alleviate some of the stresses that we have and worries we have about making the wrong product choice, because really the inevitable aim is to treat our developers as customers. And so this kind of rounds it out. Hopefully when you implement your CLI, you're now doing 50 million deployments a year. I wish you all 50 million deployments a year. But this finishes the talk. So we thank you for coming to spend some time with us. These are the 3 things we talked about today. There's a link here to Service Catalog. I encourage you to check it out. You can look a little bit deeper on the AWS website. Stelligent's spun up a little site for this talk where they've got a bunch of links and material for you. So check out the link to Stelligent, including a link to CFN nag, which is open source. You can install that in your projects today. And then at the end, go check out Click, Python Click. You can really do some amazing things very fast by creating a click-based CLI. So thanks again. The 3 of us are going to hang out over here. If anybody has questions, feel free to come up and spend a few minutes. Thanks.